Okay. In the previous video under limits, we've treated limits to 0 and limits to a number. But for this video, we'll be taking limits to infinity. So when you are given a function, let's, for example, 2x raised to power 3 plus 5x squared plus 3x all over 3x squared plus 2x. Now when you are given this kind of function and the limit tends to infinity, x tends to infinity, it can either come in three cases. The first one is when the highest power of the numerator of the variable x, the highest power of the numerator is greater than the highest power of the denominator. That's the case. The second one is, let's take for example, the second one is when the highest power of the numerator is less than that of, let's say, 2x squared plus 5x all over 3x raised to power 3 plus 7x. Then the third case is if both powers are the same. So let's say 2x squared plus 3x then all over 7x squared plus 5x. Now, the first case, the highest power of the numerator is greater than the highest power of the denominator. The second case, the highest power of the numerator is less than the highest power of the denominator. Then the last case, both powers, the highest power is equal. Now, for this first case, it says that the normal limit that we know is put this infinity into everything. Now, whenever you are dealing with infinity, you only deal with the largest powers for both the numerator and the denominator. So in your mind, all the other parts will clear out. So this, for this first question, this will just be equals to 2x raised to power 3 all over 3x squared. That's what it will reduce to because you are dealing with infinity. So when you put infinity raised to power 3 and infinity raised to power 2, definitely infinity raised to power 3 will be much more greater than infinity raised to power 2. So when you do infinity raised to power 3 all over infinity raised to power 2, you are left with infinity. So the answer here is equals to infinity. So it's like a rule that when the highest power at the numerator is more than the highest power at the denominator, your limits will always be equals to infinity when it's tending to infinity. Then for the second one, when the highest power at the numerator is less than the highest power at the denominator, that means, like I said before, you are only dealing with the highest power. So this one will reduce to 2x squared all over 3x raised to power 3. So that means all these parts will clear out and you are left with this. Now what this means is that you have a very bigger number at the denominator. Take for example, you have like 1 all over 10, you have 1 over 100, you have 1 over 1000. You notice that as this denominator increases, the value tends to 0. So that means if you have a very bigger base, if you have a very big denominator, your answer will be equals to 0. So this equals to 0. So limit of this function tends to infinity equals to 0. When the power at the denominator is greater than the power at the numerator, the answer is equals to 0. And for the last one, like I said, the other part will clear out. 2x squared all over 7x squared. So in this case, you know that when looking at it, x squared can cancel x squared out. So you are left with 2 all over 7. And that's your answer. Then a quick one. It can be given that this function is rearranged in a way that 3x comes first. Okay, like this. 3x plus 5x squared plus 2x raised to power 3. Everything divided by 2x plus 3x squared. This might look like the highest power here is x and x. No, the highest power is still 2x raised to power 3 and 3x squared. So you are still left with 2x raised to power 3 and 3x squared, which is this, and the answer will be equals to infinity.